Hello, welcome back. Uh, Today we're going to look at some other interesting concept known as arrays. Uh, I remember last time we talked about arrays. I introduced arrays and looked at the character arrays. So today we're going to look at more complex implementation of arrays. Uh, Things to do with integer arrays, and we shall see also if we can uh, understand more about the strings, something like that. So before I launch the IDE, first of all, what is an array? An array is a collection of data stored in one variable. Okay, you have multiple pieces of data, and then you store them in one thing or one variable. So basically, that's what an array is all about. So like you saw how we looked at the character array whereby we had like a string like hello, that's a string, or your name is a string in double quotes. So the individual members of the array are stored in what we call a character array. That is for your name. If you have your name or something like hello as a string, or any other string, we say the string is a sequence of characters, uh, so they are stored in what we call a character array. But generally speaking, an array is a collection of data stored in one variable. And you need not to mix up the multiple pieces of data if you are to store them in one variable. You cannot have an array uh, that has a combination of integers and then floats or doubles. No, not exactly. You have to declare, if it's an integer array, if you have to sort the data must be either integers or float or double, or you know uh, character or a string, I mean, of characters. So as we're going to be seeing how we can implement this, either say int and then the variable name of the array, or you say float the variable name of the array, but you cannot mix up the integers together with the float or the double. No, 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 no. That cannot happen. You get problems. Each must be declared independently. If at all you want to, you're working with different arrays of different data types. Okay. So let me launch the IDE and then we begin the implementation, the hands-on implementation. All right, here we go. Let me create a new file. Call it arrays. Okay, as usual, C program structure. .io h its main. So we said an array is a collection of data stored in one variable. You have multiple pieces of data and you store them in one variable. You could have a group of integers, for example. We said they must be of one data type. You don't mix them up. So if you have integers, for example, like student grades, you have a student who have grades like, for example, 20, 40, and then maybe 50. So this group of integers. So if you want to store all these together in one variable, so that will be an integer array. Okay. So how do you declare that? You say int int, then the variable name, let's say my grades. Okay, let's call it my grades. Then what you do is you put the square brackets, then you terminate. So that's how you declare an integer array. So this is the data type. We said it has to be unique, homogeneous with the same data types. Okay, if they are integers, then you have to create or declare an integer array. But you cannot mix up integers and floats or doubles. You get problems. It can't work. So, so this is an integer array. So this is the variable name, and this square bracket basically kind of indicates that this is an array. Okay, and inside here you pass what we call the size of the array. So the size of the array is the number of elements in an array. So how many are they? One, two, three. So there are three. So the size is three. So these are what we call the members or the elements of the array. 20, 40, 50. These are members or elements of the array. So you need to know that there are things you need to note here. What we call the index when you're dealing with arrays. We have what we call the index. We have what we call the element. And we have what we call the size. Okay. So we say the size is 3 as per this. It's the number of elements in the array. Then the element, they are the actual members or the values, the pieces of data which are in that array. Okay, those are members or elements of the array. Then now we have the index. The index is actually like the address. So we reference the array or the members of the array by their index. Okay, and the index is what you need to know is the index is zero based. It's something you need to know. The index is zero based. Okay, then the size is not, the element itself is not zero based. Zero is not zero based. Then the size, what you need to know about the size, that is the size is it is static, something like that. So the array is statically sized. What do I mean? Is that the index is the address or the reference of the array in the memory. Okay, and they are zero based. So what we're meaning here is that the index being zero based, that these elements 20, 40, and 50, 20 is at index 0. That's what we're meaning. Then 40 is at index 1, 50 is at index 2, and so on and so forth, in case you have more than 3 elements in that array. So the first element is at index 0. That's why we're saying the index is 0 based. It starts from 0. And we're saying the element is not 0 based. What does it mean? It means that 20 is the first element. It being at index 0 doesn't mean it's not the first element. Okay. So somebody would say, okay, 40 is at index 1. So does it mean that it is the first element? Not really. The element is not 0 based. It's only the index that is 0 based. 0 based meaning you start from 0, index 0. But the element is not 0 based. So 20 still remains the first element of the array, but at index 0. I hope I'm not confusing you. So if I ask you what's the first element of this array, is it the same if I asked what is the element at index 1? Think about that. Think about that. And tell me whether your answer you are right or you are wrong. Okay? As per my explanation. I hope I don't confuse you guys. Anyway, this is why arrays are quite interesting, and I know you like them as we go with the implementation. So the size is static. What do we mean? Is that the array is statically sized, meaning that this size here, which we declare, which we pass in these square brackets, is known at compile time, okay? And is static, it does not change. It's like when you are trying now to address, to reference the members or the elements of the array, you must know never reference an array at an index that is beyond the size that is actually what specified. Because when you pass these three into the array, that means the, you have declared an array. That means this array is going to hold only three elements or three members. So while you are referencing the members, you cannot reference the array that is beyond that, the size you have allocated. So what does it mean? If you have said the size is 3, meaning there are three elements. And if there are three elements, that means the last element is at index 2. Okay? So you can never reference an element that is at index 3 or 4 or 5 because you are past the size, the allocated size. It is static. Otherwise, you may cause something unpredictable in your code when you run it. I don't know what that thing could be. I don't know whether it will crash your computer or crash your program. I don't know, but it's never done. You can never do that. So you must always reference within the boundary or the size that has been allocated to the array. Let me show you what I'm trying to mean. So we have declared this array. So if we want to print a certain member or element of the array, what do? We do that by referencing, okay, the size. But we must first initialize this is declaration. So how do we initialize? We shall say we initialize using the variable name, my grades. So at index, the element at index 0 is, we can initialize it to, let's just use this example. This is just a comment. It's not part of the code. The code is starting here. So we are creating an array of three elements. This is why we have declared like this. And we are saying initializing that element at index 0 is equal to 20, terminate. Then element at index 1 is equal to 40, initializing. Then element at index 2 is equal to 50. So basically, this is how we initialize the, the elements or members of the array. So, we cannot initialize at index 3, no, because we declare the size as 3. That's what I was trying to mean, that statically, the array is statically sized. So these are three elements already. So if you want to print any member, we will say printf percentage %d integers, and then we reference by the index. Okay. So which member do we want to print? Let's say we want to print at index 1. Okay. So if you want to print, I mean 40. If you want to print 40, that means we would print at index 1. Because this is at index 0, it's at index 1, it's at index 2. So you want to print 40, we'll print at index 1. So when you compile this and you run it, you get 40. Okay. Basically, that's what happens. That is what happens. So there's something that you also need to know, that you can also do some arithmetics with arrays. You can add a value, you can even update an element. If you want to update the element at index 1 from 40 to maybe 70, you would just say, come here and say my grade at index 1, element at index 1 is equal to 70. So you have upgraded. So it is no longer 40 now, because if you repeat printing, the one at index 1 must print 70. Okay, it's printing 70. Yeah, this 40 was for the other one, so it is printing 70. You can see 40, 70, because it is already updated. So the first 40 was for this print because we had not yet updated. Then after updating, you see it's printing now 70. Okay, so that's how you can update the elements of an array. Okay, this one we're supposed to comment it. Okay, so another thing you can do is that you can do some arithmetics. You can add a new element, I mean a new value to, you can do some arithmetics. Just play around with that. And for example, you can add migrate. For example, the element, you can add the element at maybe index 1, or let's say 2, plus, and say plus 4, or plus 50, or anything, plus maybe 30, 33, something like that. So when you do that kind of arithmetic, then you can store this, the value you are getting here, because the element here will be 50, index 2, the element will be 50, so it's like you are getting 50 plus 33, which is 83. So should we print that result? But you need to store it somewhere. So you have to create an integer, I mean a variable. You need to create a variable, maybe x, any name, so that you store whatever result you're getting here to that variable as an integer. Then if you want to print it, you can print it here now. The value, you can print x now. Okay, so you get 83. Let me first comment this. Let me comment this, and it's so that we don't have a lot of output. Okay, so we shall get element at index 2, which is 50, plus 33, that is 83. So we're expecting to print out 83 as the output. 83. Wow, that's great. So that's how you can play around with arrays, and how that's the syntax. How you can update the array, do some arithmetics, and this is how you declare the array, and this is how you initialize. Another syntax of initializing the array can be, you can actually 20, 40, and 50. You can actually, what if now you had very many elements of the array? Would you be doing the same thing? This would be quite rudimental, because if you had like maybe 10 elements plus, even be more than 10 elements of the array, so you'd keep on initializing each on just like this on the same line, on different lines. It could be this could be quite tiresome. So the shortcut, you can just remove this. You don't pass anything here. So here upon declaration, you initialize on the same line, and this is how you do it, the syntax. You just put a curly brace, and then you terminate at the end, and then now you enter you pass now the elements. So we have 20, then you put a comma, separate them with commas. You have 40, then you have 50. Okay, this is how you can still initialize uh, the the members, or you can initialize the array with elements or members. The other one, the first one I showed you was the long way, but this is the short way. You can do it just on the same line, and that's the syntax. And this one you don't need to pass in the size, because when you use this syntax, the size will automatically be known. The size will automatically be known and be calculated. So it will already know that, oh, there are three, and it will know. So you need not to worry to pass in the size, unlike for the first method or syntax that we saw. So basically, this is what is going on here. And if you run into 3, okay. So this is how we can deal with arrays. What if we wanted to print all the members of the arrays, all of them? Because here we are printing one at a time by referencing at the index. What if we want to print all the members? What do we do? Basically, if we have to do that, let me first remove this. If you have to do that, you have to use what we call the for loop. We looked at the control flow and the for loops, and the loops. We looked at all the loops, the do while, the for, the while. So here, if you want to print all the members of the array, you can use the for loop. You create an iterator and then loop through the entire array, okay? This is what I mean. You just say for, then of course, you know the syntax or the for loop. Okay, so you create an iterator like I, int I. You start from 0, I is equal to 0. Okay, and then as long as I is less than the size, then you keep on updating I. Okay, so you must iterate through the or loop through the array. So as long as I is going to be less than the size are the members 1, 2, 3. So you must first, let's say, declare maybe the size. You can say int size. Declare the size and initialize it to 3. Okay, this is how you do it. So here I would say int I is 0, then continue iterating or looping through as long as I is less than size. Okay, then the update, each time you do that, you have to increment I. So here we're going to to put what we want the code to do for us each time it loops through. It should be printing now the value of I. Okay, and this is going to be percentage %d. We learned about loops in the previous video, so I hope you all know what we are doing here. Okay, then we print I. So we print the element, of course, the element we reference my grade at I. So this is what we do. This is how you can print all the elements of the array using a for loop. So we are trying to say we are starting from I is equal to 0. That's an iterator. And then we keep track. So as long as I is less than the size, which is 3 elements, okay, keep on updating I. And each time I is less than the size, print the elements at the index at I. So you can say and I is 0. Okay, so the first time it will see element at index 0, it will print it here, and then it will keep on the iteration looping through. Are we together? And it prints again. Now it will print 40. Okay, so it means at the beginning I was at index 0, prints 20. Then as long as I is less than the size, so it has already printed only 1, which is 20. It has printed 1 element, which is 20. So still I is less than the size because it has printed only 1 element and the size is 3. So if it confirms this that is true, then it has to of course it has printed it 20, then it updates I. So I will now be 1 from 0 to 1. So the element at 1 index 1 will be 40, so it prints it, okay, and so on and so forth until I is less than the size, okay. So that's what is happening. So if we compile it and run it, that's what we get. You can see we are able to print all the elements of the array using a for loop. All right, so that was awesome. I hope so. Let's now look at something different, although related to this. So it's still about arrays, but here we have been talking about single dimension array, because we are trying to say if a student has these grades and he wants to store them in one thing or one variable, my grades, okay, they're integers, and it was one student with these grades. But if there, like for example, maybe three students, okay, and each of them has his or her own grades, and we're trying to capture and create a structure or store that kind of structure of three students with each with his own grades, we we store that kind of structure in one variable. That means we shall have to talk about what we call the multidimensional array. Okay, the multidimensional array, or you can call them two dimension or multi-dimension, not but not single dimension. Single dimensions like you have only one thing, one row like this. So let's look at multidimensional arrays. Okay, so it's like you had once we had three students. One student has these grades, then you have another student. Okay, okay, let me remove this. So you have one student with this kind of grades, another one has 30, at least another student has 30, maybe 60, and maybe 70. Then the third student has maybe 75, maybe 80, and maybe he has maybe 90. Okay, so these are three students. One student has these grades, okay, then the second student has these grades, then the third student has these grades. So how can you store this kind of structure in one variable? So we shall use what we call the multidimensional arrays. And in this case, what we shall do is we shall store it in what we call a table format with rows and columns. Okay. So what happens? How do we declare that? So we can declare it, of course, int uh, my grades. You can still use the same name if you want. Int my grades, or no, not my, because say my is one student. Let's say student grades. Int students grades. Okay, as a variable name, and the square bracket has to be there. But now this time we're going to have two square brackets like this. This is how we can declare that. Two square brackets. One square bracket is we are going to pass the number of rows. So here you can see it's a table structure. So how many rows? These are one, two, three. There are three students. So here we have three rows, something like this. And then columns. Uh, let's say we have two students. Let's not make it so much because it is all the same. I just want to make the coding a bit shorter, but it's the same thing. So here we have maybe two rows. There are two students. Okay. So the rows we have two, and then the columns we have three. Okay. This is how we declare it. Basically, that's what we do. And initializing, you know how we do it. We initialize. So if we have to initialize now, say now my student grades, uh, so student grades at index. So the first row, you can see these are two rows. So this row is at index 0. okay? And this row is at index 1. Then for the columns, this column is at index 0, then this column is at index 1, and this column is at index 2. So if you want to initialize something like this, would say, if you want to capture this 20, would say student grades at index, so the row is at row 0, okay, and the column is still column 0. And then we say is equal to 20. And we terminate. Then we do the same, another thing, we continue. So let's first capture for one student. Let's first capture for one student. Just copy, paste. So the one student, I've captured 20, we're going to capture 20. That's for one student. This is one student, okay? So 40 is going to be at row 0. Row is at index 0, okay? Then column is at index 1. So row index 0, column index 1. Then we give it 40, okay? And we continue until we finish all of them. But that's a longer method of initializing. So the shortest way is to use the other method syntax I showed you, whereby you just declare then initialize, okay, like this, and you put the curly brace and terminate here, so that inside here you come and what? Capture the elements. So how do you capture now the elements? And remember, when we were declaring that, we would not, when we use this syntax, we are not worried about putting this the size inside the what? Inside the square brackets. So basically that's what will happen. So so this is what we're going to do is we're going to you're going to include now you pass the other members. Remember, in the single dimension we are passing, we had only one student, but here I have two. So we have two rows. So here we pass the number of rows. But how do you do that? So you have to capture the elements. You have to put another curly brace, and you put the elements in the first row. So we have 20. You separate by comma. We have 40. Separate by the comma, and then we have 50. After that, you have captured the first row, that is one student, then you again put a comma, sorry, not a full stop, a question mark, put a comma, and then capture the other row, the second row. We have 30, we have 60, we have 70. So that's what you do. So I think this is a better syntax, very simple and short, doesn't take time like the other one. So this is all. So this is how you do it. And for example, if you wanted to now print the any element at any index, okay. For example, if you wanted to print 60, element 60, what would you do? It means you would print, you difference it. 60 is positioned at row at index 1, column also at index 1. You see, if you want to print 60 is at row index 1, then column index 1 also. So that is what is happening. So let's try to print 60. Well, what we'll do is that we'll say print, of course, print F, and then say percentage %D, in grades. So we're trying to print 60, then we reference the index. So the row where 60 is positioned is row at index 1 and also column at index 1. So they will be able to print 60. Let's run it. Oh, oh, in student grade. Oh, we need to specify, I think, let's say these, how many, the columns, how many, what's the number of the columns? One, two, three. Let's say three. What about the rows? Do we also need to put two here? Let me first compile this. It is still misbehaving. Let me say two. Wow. Okay, so I think let's first declare the variable here called size, int size, and we initialize it to size. No, the size. So we have int column. Okay, int column. We have rows and columns. So int. Let's start with the rows. Int rows is equal to maybe two. Okay, because there are two. Then int columns. Int columns is equal to columns are three. So, and here we just pass in the and even pass the name since we have already declared them. This is column. Okay, columns, and this is number of rows. So it's still complaining. It is still complaining. Okay, where is the problem here? Oh, let's first wait. Let's see if we don't initialize. Okay, can't. Wow, why is it running and then giving me this? Okay, so let me see. What if we use the other long method? Will it be able to work for us? What if we initialize using the long way? I mean, if you say student, mm, if you use students grades, let's try to see if we can use this. So 20, I'll put 20, then have six of these. Okay, 20, then the other one is 40, then the other one is 50, then the other one is 30, and then we have 60, then we have 70. So 20 is at index, row is index 0, column uh, to index 0. Then 40 is row is index 0, column index 1. Then 50, row index 0, column index 2, index 2. Then 30, row is index 1, column index 0. Then 60, row index 1, column index 1. Then 70, row index 1, column index 2. So if we initialize like this, so let's try to comment this so that here we have declared the rows and then the columns, and let's say mm, uh, column is equal to the columns are 3. Okay, then the rows are 2. Let's sometimes you may need to declare only the columns and to initialize the columns and leave the rows because it can easily be calculated. Let's first run this. So as you can see, what is here? Students grades. Oh, we did not declare the variable students, the array itself, int students grades. I think that's students grades. Then let's command. We have declared this array students grades, and we have, of course, let's put it below this. Okay, so the rows here, this is columns, and here will be rows. Okay, so as long as we have initialized the columns and the column, then it's okay. You may not necessarily need to put the word rows inside here, or you may not need to initialize it to 2, the rows, though we know it is 2. Okay, it may not comply. Let's try to compile this. Wow, wow, student grades. Why is it compiling rows? Do we need to put rows here? Oh, it's coming back here again. Or what if we just try to initialize it? Try to run it. Still complaining. Okay. Intros to column. Should we use the word constant here? Constant, so it doesn't change. Okay. Then also constant. Will it work for us? Still not working for us. So what could be the problem here? Okay. What could be the problem here? There is a problem. I think it wasn't all about the syntax, changing the syntax. Let me see what could be the problem. student grades. Here we are trying to declare the size. Okay, and you are saying, I think this is double declaration. So let's remove this. Let's remove this and just say int student grades as double declaration. Okay. So there's a problem here. What could be the problem? Columns, rows. Let's put rows here and see. Okay, rows. Still the same. Okay. Okay. So there's a problem with this line here. Okay. Okay. Let's try to put values. Three. Let's fight with this quad. It has to work. Let's try to put three, then two here. Okay. So in that case, what happens? Not yet. Okay. Not yet. Not yet. Not yet. Not yet. Not yet. Not yet. Okay. So let's try to do what? Is it because of this? This has to be there. It has to be there. Oh, wait, wait. It was because of the termination. Are you sure it's not supposed to be there? Printf percentage %d. Really? Okay. Remove this. Okay. 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 So we have, let me see. Let me see. There's a problem with the code. two rows and then three columns. Two rows and three columns. Okay, let me comment this again. And use this long method, and then after, okay, okay, then remove this and declare this. Let's declare this, and of course this is, so we have declared the variable name, the array, and I've passed in the size. The size, of course, the columns are 3, the rows are 2. And I'm gonna use this method, long method of, or syntax of initializing the members. Then we are printing this, okay, the member at row 1 and column 1, okay, index, the row at index 1 and the column at index 1. So let's compile this. Wow, it's working. Ah, it has been a pain in the back. Wow, coding can be so much overwhelming, and you must always be used to this. Sometimes the code may fail, and you really need, you think of even first taking some cup of tea to refresh your brain and think again. So it shouldn't be so much overwhelming to you. If you feel that you're really caught up in a corner, try to refresh yourself, take a cup of tea, and come back and look for the bug and debug and look for the error and then continue. So basically, that's what you can do to avoid all those hiccups and troublesome and overwhelming scenarios or situations you meet while you're coding. Just have a break, refresh, take a cup of tea, come back, look for the error again, and consult, go online, seek assistance from online communities if at all you feel you need to do that. But for now, I think we are able to resolve the error. So this is what we're having. Okay. So I think there was a problem. We're using the other method, syntax of initializing here. Okay. And yet we had already this, because we said when you initialize and you put the curly braces, then you must not specify these sizes. But if you use this syntax of initializing in a long way, then you must first specify these sizes in the declaration of the variable. So I think the error is gone. Then when you compile, that's perfect, and then you run. So if you run, you're going to print the element at the row that is at index 1, at the same time the column that is at index 1. So row index 1, this is row index 0, this is row index 1. Then column index 1, column index 0, then column index 1. So we're going to print 60. So when you run this, you get 60. Perfect. That's very perfect. So this is how you can deal with arrays. I mean multi-dimensional arrays. So what if you wanted to print all the members or all the elements in a multi-dimensional array? So how do you do that? We saw how we could print the members of a single dimensional array, all of them, using a for loop. So how about if you want to print all these members in a multi-dimensional array? Still, we'll use what we call a for loop, but we shall use what we call a nested for loop, a loop in another loop, a for loop in another for loop. So the first for loop or the outer loop will print the rows, okay, and then the inner for loop will print the columns. So basically, that's what we shall do. So let's comment this. So we shall say the for loop. We shall have two of them. So we have create an iterator int I. Okay, we shall just create an iterator that is going to, so the first for loop is going to print the rows, and then the second for loop will, or the inner loop will print the columns. Basically, that's what will happen. So we shall say create an iterator int I. We start from 0. That is for the first for loop. That is for the number for the rows. Okay. Then we terminate. I mean, we put a semicolon. Then, as long as I is less than the number of rows, okay. But we need to have declared the variable somewhere here called rows, int rows, okay, int rows somewhere here, and also int column, int columns somewhere here, okay. So having done that, then int rows. So then we say every time we test that, then we have to increment I. Every time we test this and we print the elements, then we have to increment I. So basically, this is what will happen. So, before we print now, we print the columns. We must first put another for loop, okay, like this. Put another for loop for capture the rows. So this one will be for the rows, okay. So we can use another iterated different one, then maybe J, okay. So the choice is yours. So J, as long as J is less than the columns now, okay, then J must be incremented. So each time you do that, each time you go through the rows, you have to go through the columns, and after going through the columns, because you see, when you look at something like this, you have the rows and you have the columns. So if you are at 20, you are at this row. So each time you print an element of this row, like 20, then the one of the element of the column must also be printed, okay, which is 30. So when you do that, so each time you print a row and a column, okay, you must increment the rows and you must increment the columns. So this one will be here now, okay. The print will be here inside the inner loop, inside the inner for loop. Percentage D, student grades, okay. So the first one will hold the row, that is I, and the second one for the columns, element at J. Okay. Basically, that is what happens. So if you want to, let me first compile this and then run it. Okay. Wow, it's not bringing it out. Why? Why is it not coming the way we want? Why is it not coming? Okay, okay, okay. Why is it not coming? Is it here? Okay, constant. Let's keep this constant. Let's keep let's keep the number of rows constant so that they don't change. This is a keyword. Constant is also another keyword in C. So making the variable constant kind of informs that this variable must never change during execution of the program code. So let's compile this again and then run. Still the same story. Okay. We need to initialize. Let's initialize the columns, the number of columns to 3 here. Let's keep it initialized. Okay. Whoa. What was that? Okay, initialized to 2. So it's printing DDDD. What's this? Okay. Did we print? Hold on. Okay. Let me see what we went wrong here. Oh. I think we're not printing. We need to the conversion specifier. Conversion specifier. The conversion specifier here. How couldn't I see that? So we are trying to print the elements, but we're not specifying the format with which they should be displayed on the console. So they should be integers. So when we compile again and then run, this is what we get. So we have 20, 40, 50, 30, 60, 70. So all of them are printed. That's interesting, but they are quite not organized. But if we wanted to print them in a table format, the way they appear, so we must so the type if we print the first row before we print the column, we must print a new line. So we have to print a new line. Where should we print a new line? Okay, so when you print this. I mean, when you iterate through the first for loop, then the inner loop, then you print it. So when you come out of the inner loop for the columns, okay, but this is still within the rows. So each row, after printing each row, we must print a new line so that another row goes down. Okay, so we must put the print new line after the for loop of the rows. So after the yes should be outside the for loop for the rows. So if each row, having printed each row, go to the next line so that another row goes down. So let's put it outside the for loop for the rows. Just print a new line. Just print a new line, just like this, so that we organize them. Okay. Oh, it's not coming. It's not coming. This is the for loop. Okay. Okay. Let's compile and run it. Still not splitting them. So this is for 20, 40, 50. After reaching 50, then it should go down so that 30, 60, 70 should be on the new line. That's what I'm trying to do. That is what I'm trying to do. That is what I am trying to do. I need to initialize this. Whoa. Then two. This is what we have. Still, it's not separating. Where should we print the new line? Is it supposed to be here, or we put it here? Let's put it here and see. Okay. All right. This is what we wanted. That's that's really nice. So you can see the second row is on another line. We wanted to come up with something just similar to this structure. So that is where the print F of the new line was supposed to be. So, okay, it's within the for loop of the rows, but outside the for loop of the columns. Okay, so it's like after printing this, okay, after printing this row, the elements of this row, then you come out to the next line before you start another row. Okay, yeah, that is basically what happens. That is basically what happens. So maybe they are close to each other, but if you want to set to put some spaces, you can use a tab key, or even a space can work here. You can put just a space like this. Okay, so just put a space and then see. Okay, yes, something like that. You see, there are some spaces. That's great. Otherwise, if you use the tab key, if you came here and use the tab, I mean the tab key, the character for the tab key, which is denoted as the back slash then T, then the space would be bigger, like the way you press a tab key, something like this. So you can either choose to use a tab, the character for the tab key, which is the back slash T, or you can just leave it and just put a space, okay, and you get something like that. All right, that was multidimensional arrays and how we can print all of them uh, using the nested for loop, a loop in another loop. So having done that, I think let's look at, I think this is all about arrays. This is all about arrays. Uh, or maybe if I can make a review on strings, whereby we have what we call character arrays. I remember in one of the videos previously, I showed you how the strings work and how we store them in a character array. But just to make a recap on that, I said that first get rid of this. To make a recap of that, I say that a string is a sequence of characters in double quotes. So if you have a string like hello, sequence of characters in double quotes, and you have how many characters? 1, 2, 3, 4, 5. So to declare such a string, you'd say you say char, that's the data type. Let's do it here. Say char, maybe my string or something like any name, and then you put the curly, I mean the square brackets, and then you initialize if you want to initialize it, but should be in what we call the double quotes, something like that, and then you terminate. So this is what happens. This is a string. Okay, so for example, if you wanted to print it, you'd come with this and say, and we saw that the conversion specifier of a string is percentage %s. Okay, then you wanted to print it out. So this is what would happen. It will print hello, okay, as a string, just like that. I remember digging deep on the strings, how you could come up with an app that complements. You enter your name and then it complements you. Just go and read, watch that video on strings. I already created it. I hope you guys went through it. How you can enter your name, you scan, a string, from the console or from the user with either one name or both name, the first name and the last name. And I saw how you can compliment a user, having entered his name and say, "Oh, hello, so and so, welcome. You look nice today." All that stuff. There's a video created that I created on that. Please go through it. So I was just trying to give you an overview of that. And then another thing is that we have what we call string functions. We have what we call string functions. You could use string functions to deal with strings. You can count the number of, you know, strings that are in, the number of characters that are in a string, something like that. So you could say, for example, if you wanted to count how many characters are in this kind of string, this one here that we are just having here, which is hello, it is a string. So we could say maybe if you wanted to count you could come up with a what? A string function. Some of them are inbuilt actually. These are inbuilt functions. So for example, you can say maybe you declare variable is going to hold that count. Let's say maybe it is called character count. Just declare the variable and initialize it. So it's going to be, so uh, you call the function maybe for counting. So it's called string length. But we need first import a library here that is going to help us use some of those inbuilt string functions, okay? So that library is going to be string. Is it string? Okay, string. Okay, string. Do we need this? Let me see, string.h. Yeah, is this string.h? So it will help us to use some of these inbuilt functions or string functions. So you can, for example, if you want to count how many characters are in this string, which is hello, we have already declared it and initialized it. And if you want to count, you can say maybe let's declare this. We have declared the variable to hold that value of the count. It's an integer character count, so we call the function string length. All this, so having included the other or imported the other string library, string.h, you are able now to access all this. So in C string, we have string, we have string case, string card, we have all these are string functions that can do anything. You can change a string from lowercase to uppercase. You can change a string. So for example, if you want to know the length, how many, so you can use this is, you see the string lower. These are case for uppercase and lowercase, but the one we want for now is string length. Let me see. Yeah, is this one here. This is what we need. So when you say yes, we enter it. So when you say string length, then what do you have to do? Then you have to, okay, you put this is the syntax. So here you have to call now you pass in now the variable, okay, of the variable name for the string that you want to know how many characters or its size, basically the members, okay. So, and we give it a name called my string. So you just bring this. When you run this, when you print now, and now print the character count, now print the character count, and this one is going to be an integer, of course, percentage %d, okay, character count. Basically, this is what is going to happen. So here for the string, we don't pass the address of operator or the ampersand. No. For strings, you don't worry about that. So let's compile this. And it is giving us hello, then it's giving us 5 because hello has 5 members. Let's try to maybe print it on another line. So it's a new line here, and then try to print it here on another line. Okay, so this is it. Hello, it has 5. So this we have used the string function to do that. You can even use another string function to change it to uppercase, you know, from lower to uppercase. So there are many string functions. I don't know. Oh, what did I do? It's here. There are many string functions. You can reach out to the internet and try to understand the functions, the various functions of the strings. You can deal with strings. You can change them from lowercase to uppercase to lowercase, get their number, concatenate them. You have one string, you combine it with another. So all that stuff is how you can do a lot of stuff. I mean, a lot of things with the strings or string functions. Excuse me. So, meanwhile, this has been a long one. I think this is has been interesting, and this is the end of arrays. With this video and the other one that I prepared in the beginning about strings, then when you add also this, I hope you'll be able to really appreciate arrays and strings. There's a lot you can learn. You can use the internet, go there, but what's important is you need to understand what the code does. You must be able to interpret the code a statement by statement, be able to know what is this line doing in the code. That's the best way you can learn programming. Okay. Um, have a good day. Wish you the best. Bye bye.